The largest piece of stone ever worked by human hands is not in a museum. It's not on display anywhere. It's lying in a pit in southern Egypt, exactly where it was abandoned roughly 3,500 years ago, still attached to the bedrock, still half-carved, still waiting. And the reason it's still there is not what you've been told. The official story is clean and simple. Ancient Egyptian quarrymen began carving a massive obelisk from a granite outcrop near Aswan. Partway through the process, a crack appeared in the stone. The crack made the obelisk unusable. Work stopped. End of story. That explanation satisfies the textbooks. It explains why the stone never moved. It gives the whole thing a tidy beginning, middle, and end. What it doesn't explain is this. Even without the crack, even if the stone had been perfect, there is no engineering method on record, ancient or modern, that can account for how the Egyptians planned to move it. Not transport it to its destination. Not erect it. Just get it out of the pit. That's the part no one talks about. The Unfinished Obelisk of Aswan measures approximately 42 meters in length, taller than a 14-story building. Researchers estimate its weight at roughly 1,200 tons. For comparison, the largest obelisk ancient Egypt ever successfully quarried, transported and erected was the Lateran Obelisk, now standing in Rome, which measures about 32 meters tall and is estimated to weigh around 455 tons. The Unfinished Obelisk would have been roughly 1/3 taller than that, and nearly 3 times heavier. It would have been, by an enormous margin, the largest obelisk ever attempted in the ancient world. The people who began carving it knew what obelisks were. They had built dozens of them. They understood granite. They understood logistics. They had a flawless institutional memory of what it took to move stone across hundreds of miles of desert and river. And they decided to attempt something nearly 3 times beyond the largest thing they had ever successfully achieved. Why? Before we get to that, you need to understand something about how obelisks actually worked. Because the answer to that question changes everything about what happened at Aswan. An obelisk is not a construction. It's a declaration. Theologically, an obelisk was a solar monument, a sacred object connected to Ra, the Egyptian sun god. The tapered shaft and pyramid-shaped peak, called a pyramidion, were designed to catch the first light of sunrise. The obelisk connected the earthly realm to the divine. It was the physical manifestation of the pharaoh's relationship with the cosmos. But here's the part that made obelisks an engineering nightmare. They had to be carved from a single piece of stone. 1 block. Base to tip, no joints, no seams. The theological requirement was absolute. A seam would have shattered the symbolic integrity of the monument. This meant that to build an obelisk, you couldn't assemble pieces. You had to find a granite outcrop large enough to contain the entire finished object. You had to separate it from the bedrock intact. You had to transport it whole. And you had to raise it vertically at its destination without breaking it. Every single step was extraordinary. The Egyptians succeeded approximately 30 times over several centuries. 30 major obelisks were quarried, transported, and erected during the pharaonic period. Some of them moved hundreds of kilometers from Aswan to temple complexes at Luxor, Karnak, and Heliopolis. The logistics involved specialized wooden barges, earthen ramps, and human labor on a scale that remains difficult to fully comprehend. Those 30 successes are impressive. But none of them weighed 1,200 tons. Most people never question this part. The quarry at Aswan is on the east bank of the Nile, on the outskirts of what is now the modern city. The granite there is pink, a distinctive, fine-grained stone that the ancient Egyptians prized above all other materials for their most important monuments. The quarry was active for thousands of years. The marks of that activity are still visible everywhere. Unfinished cuts, abandoned extraction attempts, tool marks in the stone. The unfinished obelisk sits at the bottom of a trench that was cut around it. 3 sides were completed. Workers had carved channels on the north, south, and west faces, gradually separating the obelisk from the surrounding rock. The east face, the bottom, the face that was still attached to the parent bedrock, had not yet been separated when work stopped. Then the crack appeared. The crack runs diagonally across the body of the obelisk. It's visible today to any visitor. It would have been a catastrophic flaw. Internal stresses during transport and erection would almost certainly have caused a cracked obelisk to shatter. The crack made the project impossible. Work stopped. The obelisk stayed. That much is documented. That much is real. But here's where things get strange. The crack explains why the obelisk was abandoned. It does not explain what would have happened if the crack hadn't been there. The quarrying method attributed to the ancient Egyptians for projects like this relies primarily on a technique using dolerite hammerstones. Dolerite is harder than granite. By repeatedly striking the granite surface with dolerite balls, workers could gradually pulverize the rock, creating the extraction trenches visible around the obelisk today. The evidence for this technique is real. Dolerite balls have been found at Aswan quarry sites. The characteristic shapes of the trenches are consistent with hammerstone pounding. The technique works. Experimental archaeology has confirmed this. The question is not whether it works. The question is what happens next. Assume the crack never appeared. Assume the 3 completed sides are perfect. Workers now need to separate the bottom face, the face still attached to the bedrock. The mainstream hypothesis involves cutting slots into the stone, inserting dry wooden wedges, and soaking the wedges with water so they expand and split the granite along a predetermined line. This technique is documented in later quarrying traditions. Whether the Egyptians used it at this scale is less certain, but even setting that aside, assume the separation succeeds. The obelisk is now fully detached from the bedrock. It is lying in a pit. The pit walls are granite. The obelisk is 42 meters long and weighs approximately 1,200 tons. How do you lift it out? This is the question the textbooks don't answer. You cannot roll it. The cross-section is rectangular, not cylindrical. You cannot drag it up a slope. The quarry geometry does not accommodate a ramp of adequate size, and the friction involved in dragging 1,200 tons across any surface would exceed the breaking strength of any rope system the ancient Egyptians are known to have possessed. The mainstream hypothesis involves earthen ramps built within the quarry and coordinated human labor. But this hypothesis has never been tested at anything close to the relevant scale. The math gets worse the closer you look. In 1999, a PBS documentary followed stonemason Roger Hopkins and Egyptologist Mark Lehner as they attempted to quarry, transport, and erect a small obelisk using ancient methods. They succeeded. The obelisk they worked with weighed 25 tons. The unfinished obelisk would have been roughly 48 times heavier. The experiment proved the techniques work. It did not prove they scale. And this is the critical distinction that the official account slides past without acknowledgement. Physics does not scale linearly. A technique that works for 25 tons does not automatically work when you multiply the weight by 48. The forces involved, friction, leverage, rope tension, the stress on wooden sledge runners, compound in ways that outpace the workforce and materials available. History tells us one thing. The engineering says something else entirely. The transport problem is just as severe. The ancient Egyptians moved their obelisks down the Nile on specially constructed wooden barges. We have documentation for this. A relief carving at Hatshepsut's mortuary temple at Deir el-Bahri depicts 2 obelisks being transported on a barge, the vessel surrounded by smaller escort boats. Scholars have estimated those obelisks depicted in the relief weighed approximately 320 tons each. The barge capable of carrying the unfinished obelisk would need to support nearly 4 times that weight on a single wooden hull. No evidence exists that such a vessel was ever built. No ancient text describes one. No depiction survives. The assumption is that the Egyptians would have built one, because they clearly planned to move the stone. But planning is not the same as capability. There is a useful comparison in more recent history. In 1586, the Lateran Obelisk, a 330-ton Roman-era monument, was relocated approximately 250 meters across St. Peter's Square. The project was entrusted to architect Domenico Fontana. It required 900 men, 75 horses, and 40 capstans, a sophisticated arrangement of ropes and pulleys that represented Renaissance engineering at its most advanced. The move succeeded. That obelisk weighed 330 tons. In the 19th century, two ancient Egyptian obelisks, now known as Cleopatra's Needles, were moved to London and New York. The London obelisk, weighing around 200 tons, was transported inside a specially built iron cylinder that functioned as a floating vessel, towed by a steamship, and nearly lost in a storm in the Bay of Biscay. The New York obelisk, similar in weight, required U.S. Navy logistics, custom marine cradles, and months of planning. These were 200-ton stones. They were moved with 19th-century industrial technology, with enormous difficulty. The Egyptians intended to move 6 times that weight, with Bronze Age tools. This is where the analysis becomes genuinely uncomfortable. The people who commissioned the Unfinished Obelisk were not reckless dreamers. The engineers of ancient Egypt had accumulated centuries of hard-won knowledge about quarrying and stone transport. They had built the infrastructure at Aswan across generations. They knew, precisely and intimately, what their workforce could do. To assume they simply miscalculated, that they began a project 3 times beyond anything they had achieved without any plan for completion, is to assume a level of incompetence that nothing else in the Egyptian engineering record supports. The Egyptians who carved the Lateran Obelisk, who moved the Colossi of Memnon, who engineered the temples at Karnak, those were not people who made casual errors of this magnitude. So what are we left with? There are 3 possibilities. The first is the conventional answer: they overreached. The crack was a disaster. But perhaps a lucky one, it stopped a project that was always going to fail when it reached the transport stage. This interpretation is possible. It is also condescending to one of history's most sophisticated engineering cultures. The second possibility is that they possessed techniques we have not recovered. There are features of the Aswan quarry surfaces that some researchers argue are inconsistent with simple hammerstone pounding, surfaces finished to tolerances that hand percussion does not easily produce, corners sharper than dolerite ball strikes would typically create. These observations are contested. They have not been resolved. The possibility that our understanding of Egyptian quarrying methods is incomplete is not fringe speculation. It's a straightforward acknowledgement of what we can and cannot demonstrate. The third possibility is the one nobody wants to say out loud: that we have systematically underestimated what Bronze Age civilizations were capable of, and that the Unfinished Obelisk is the most honest piece of evidence we have for exactly that gap. The stone is still in the pit. The quarry is still open. Visitors can walk to the edge and look down at it, and the explanation offered to those visitors, dolerite hammers, wooden sledges, an unfortunate crack, has not changed in any meaningful way since the British Egyptologist Reginald Engelbach first documented the site in 1922. The questions that engineers raise when they examine the numbers are not addressed on the interpretive signs. The scaling problems are not discussed in the visitor center. The assumption is that the Egyptians knew what they were doing, which is almost certainly true, and that we understand what they were doing, which may not be true at all. Here is what we actually know. The obelisk is real. Its dimensions are measurable. Its weight can be calculated. The crack that stopped the work is visible to anyone who visits. The quarrying technique that produced the extraction trenches is documented and has been replicated experimentally. Everything after that point, extraction, transport, erection, is an assumption dressed up as an explanation. No one has demonstrated how a 1,200-ton stone block is lifted from a granite pit using Bronze Age materials. No one has demonstrated how it is loaded onto a barge that didn't exist. No one has demonstrated how it is raised vertically at its destination without the forces involved destroying both the stone and the structure built to receive it. These are not rhetorical objections. They are engineering questions with no published answers. The crack saved the Egyptians from having to solve them. Or maybe it saved us from having to admit that they could, because here is the thought that stays with you after you've looked at the numbers long enough. The people who started carving that obelisk were not guessing. They were not overconfident. They were among the most experienced monumental engineers in human history, working within a tradition that stretched back centuries. They began quarrying 1,200 tons of granite because they believed they could move it. The question isn't whether they were wrong. The question is, what did they know that we don't?